Hey guys, in this video we're going to take a look at solving rational equations. Rational equations are equations that contain fractions, okay? And rational expressions, which are the fractions that we're talking about here, are fractions where the numerator and denominator are both made up of polynomials, okay? For example, you might see something like 3 over x plus 2 minus 2 is equal to maybe 7x over x plus 2, something like that, okay? That is a rational equation. All right, the excluded values are numbers that make the denominators equal to 0, okay? We call them excluded values because you can't divide by 0. So those particular values are excluded from the solution, okay? So for example, in this little equation that I've written here, we could find the excluded value by setting each different denominator not equal to 0 and solving, okay? So let's see what that would look like. I'm going to do this in red off to the side. We have one type of denominator. I guess type is the right word here. Okay, both denominators are the exact same factor. So all we have to do is set that one factor not equal to 0, and then we just solve that, okay? Just like you would regularly solve an equation. So if I subtract 2 from both sides here, I get x is not supposed to be equal to -2, and so that is what you would look for when you do your solution for this particular equation, and then you would just make sure that the solution was not -2. If it is -2, then if it happens to be the only solution, you have no solution, okay? But if you get a couple of different answers, and -2 is one of those, then you just mark out that particular answer, and the other solution is your solution, okay? So let's take a look at the steps for solving a rational equation. This is the process you go through each time you go to solve a rational. The first step is to set each denominator not equal to 0 and solve. Okay, that's what we just did with to find the excluded value. Then you're going to find the least common denominator. You're going to multiply each term by the LCD and then simplify. Now what's going to happen here in this step, that least common denominator is created from all the different factors in each denominator. So if you multiply each term by that, then you're going to be able to cancel the denominator of that particular fraction with part, at least, of the least common denominator, okay? So we're able to get rid of the denominators in that step. This step's actually called clearing the denominators. Then whatever's left behind, you're going to solve that equation. You might have a linear equation left, you might have a quadratic equation, okay? And in more complicated equations, it might even be a higher degree polynomial that's left behind. Then once you find your solution, if a solution matches the excluded value, throw it away, okay? So if the whole solution, if the only solution you get is the same as your excluded value, then you will have no solution. If you have a little bit of solution, like if you get 2 answers and one of them is the excluded value, you just toss the one that's excluded, okay? So let's take a look at an example to see how we work through this. This example, I believe, is in the textbook. So what we're going to do is find the excluded value first, okay? And to do that, I set each one of the denominators not equal to 0, and we'll just see what we get from each one of those. Okay, so my first one here, what does this give us? If we solve that for x, what are we going to find that x is not equal to? We're going to see that x is not -3, okay, or should not be -3, and then do the next one, solve that one for x, and we find that x is not equal to +1, okay? So these are the 2 excluded values. Okay? All right, so move on from there, and we find the least common denominator next. Okay, least common denominator is made up of each different factor in a denominator. So in this problem. We've got two fractions. One right here with a denominator of x plus 3, and then another one here with a denominator of x minus 1, okay? Each one of these is a polynomial over a polynomial. So what we do is we take a look at our two denominators, and they're both factors, okay? One's an x plus 3 and one's an x minus 1. And so I'm going to need both of those to be part of my least common denominator. So x plus 3 times x minus 1. You'll probably find that most of the time you wind up multiplying the denominators together at this point. Occasionally you'll get one where maybe one denominator is squared. You know, maybe it's a binomial squared or whatever. And you may have a repeated factor, but you want to look out for that. But a lot of the times, all you have to do is just multiply those two together. The truth is, as long as you've got a common denominator, it does not have to be the least common denominator. So if you get too many factors down there, it'll be okay. You just may wind up with larger numbers than you intended to. Now what we do is we multiply that times each one of the terms. You can do this separately. Just work on one term at a time and then put them back together if you want to. Or you can put it together all in one equation. It's going to be a little tricky for me to do that on this screen because my screen is not super wide. I'm going to scoot up just a little bit so I can still see kind of what I'm doing while I'm writing this down. So y'all forgive me if I run off the side of the screen and have to put part of it down below. Oops, wrong symbol. Alright, so what I'm doing here is I'm taking that least common denominator. I like to put it over 1 when I'm going to be multiplying times another fraction. And then this is the first term of my equation up here, okay? So we're multiplying the least common denominator right here times this first term right here, okay? And then I'm going to go ahead and write the rest of the equation as much as I can anyway. The second term is going to be 5 times x plus 3 times x plus minus 1. We're going to need a little quadratic out of that. And then this last term, this is the one I'm going to have trouble fitting in, I think. X plus 4 over x minus 1. I guess I'm going to have to drop down a little bit to put this in there. We're going to have x plus 3 times x minus 1 over 1. Still didn't really give myself enough room. Times x plus 4 over x minus 1. Okay? And as we go through here, what I should have done is just gone ahead and written it out. I'll tell you what, let me backtrack and do that. I forget that I've got extra room on this screen. So y'all forgive me for just a second. Let me kind of drop back and punt and scoot over a little bit. All right, x plus 3 times x minus 1 over 1. And we're multiplying that by the x plus 4 over x minus 1. Now what I can do, I think... Okay, I think I got it arranged here where y'all can see the whole thing on one screen. All right, so now what I do is I go down through each individual term, and I just start them one by one and work on it kind of in pieces, okay? And what I've done there is I've kind of visually given some separation to the terms so it's a little easier to see what I'm working on at one time. So we're going to start with this first one, okay? And what we're looking for is we're looking to be able to simplify this, so check your denominator and divide, or not divide, but cancel the denominator with whatever part of that LCD numerator will match it, okay? So in this case, I'm canceling out the x plus 3's. Now what that leaves behind, we have to go ahead and multiply out, and I'm going to do this in black so we can see a little bit better. So I'm going to distribute the 2x to that x minus 1, so 2x times x and 2x times negative 1, okay? And now what I've got here in the second part is I've got a negative 5 times these two, okay? So what we might want to do here, I can't do that all in one step. I'm going to leave that negative 5 multiplied by what we get when we multiply those two together, okay? Grab the wrong thing. I meant to grab that instead of the pan button over to the side. Okay, so we multiply those two binomials together, and we're going to get x squared. I'm going to get a negative 1x when I do the outer terms, and then a positive 3x for the inner term product. Negative x plus positive 3x is going to give me a positive 2x. And then we multiply the 3 and the negative 1 to get negative 3. And now down here on the end, this very last one, we look to see what this matches with, and it matches to this one. The 2x minus 1s will cancel. So I'll go ahead and do that. And then when I multiply that together, we can go ahead and multiply that out. And I've got x squared, x times x. Then we are going to have x times 4, so 4x. And then 3 times x gives me 3x. 4x plus 3x is 7x. And then 3 times 4 gives me 12. Okay, so that's where I am. I've canceled my two denominators and I've multiplied out what I had. You can do that a couple of steps if you need to. You don't have to go as far as I did in just that one step. I am going to go ahead now and do that distributing the negative 5, okay, right here. And then we'll combine our like terms and start solving. This is going to be quadratic, as you can see. So I've got 2x squared minus 2x minus 5x squared minus 10x plus 15. All I've done is distributed the negative 5 there, is equal to x squared plus 7x plus 12. Okay, so let's get our x's together and our x squareds together, do all that kind of stuff. We want to combine our 2x squared terms there. So that's going to give me a negative 3x squared. We need to combine the negative 2x and the negative 10. That's going to give me negative 12x, and then the plus 15 is our constant. And we're trying to move everything to one side. I don't particularly care for factoring when we have a negative on the x squared term, so what I'm going to do is move everything from here over here. Okay, so that's going to give me a 0 on the left-hand side. And let's see, if I add 3x squared to both sides, we're going to get a 4x squared. If I add 12x to both sides, we're going to get plus 19x. And then if I add 15 to both sides, we're going to get plus 27. Okay? So now we've got to do a little factoring. I don't have a common factor that I can factor out of that. So we need to factor into the product of two binomials. And we've got a leading coefficient and a constant that have several factors. For 4, you could do 1, 2, or 4. For 27, 1, 3, 9, and 27, I believe that's all of them. Okay, so the one good thing is that we know both signs are going to be plus because it's a positive 27, and we have to combine to get a positive 19 when we do our products. And so we know that we've got to add the two together. And what that tells me is that most likely we won't be needing the 27 because that's going to be too big. So 1 and 27 are out. So our constants that we're going to use are going to have to be 3 and 9. So we're going to go ahead and set those in. It'll be plus on both. Okay, and we've got to add our products to get to 19. So let's see what we could do. If we put the 4 with the 3, multiplied by the 3, and the 1 with the 9, we'd have a 12 and a 9. That's too big. We can't do 4 and 9 because that would be 36, and that's too big. So it looks like our 2's are what we're going to need. Well, when I use 2 for both, that's going to be too big as well. I think we may have one that actually won't go by factoring. Let's use the quadratic formula. Okay, our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And you've used this before. You used it in the previous section when we were talking about doing finding the solution to quadratic equations. It's fairly simple to do. We just plug numbers in, see where it goes. simplify, and get our solution. So I've got a 4, a 19, and a 27. 19 is our B value, 27 is C, and 4 is A. So let's see what we've got when we plug this in. X is equal to negative 19 plus or minus the square root of 19 squared. Okay, and 19 squared is 361. And then I've got 4 times A is another 4, and then times 27. So it's going to be 16 times 27. All right, and that's 432. Divided by 2 times A is 4, so that's going to be 8 on the bottom. Kind of weird looking numbers, aren't they? All right, so X is equal to negative 19 plus or minus the square root of 361 minus 432. This is going to give us a negative value, so we're going to wind up with an imaginary number. And that's going to give me negative 71 over 8. It's kind of weird looking, isn't it? All right, so we've got, at least we know it's not an excluded value by having this kind of strange number here. All right, so negative 19 plus or minus, well, we really can't reduce this any, so I guess maybe writing it in 2 pieces. Negative 19 plus the square root of negative 71 over 8. And negative 19 minus. This is what you'll use if you run into a WebAssign problem. Just split it up like that, okay? So the answers are a little stranger than I had really intended for them to come out to be when I picked this problem. But I think this is probably about as bad a one as you would see. Most of yours that come out to give you quadratics are probably factorable. And you should get, oh, I forgot to take the imaginary number out, didn't I? So we do need to do that. I'll go back to this form. Plus or minus I on the square root of 71. I apologize. I was so caught up in the fact that this answer is kind of weird that I forgot all about it being imaginary. So we do need to pull the I out. And of course, if you've got it in WebAssign, you'll split it up and do it in 2 pieces. So there you go. Most of the homework problems should come out a lot easier than this one. You may run into 1 or 2 that require the quadratic formula to finish, but like I said, most of them that turn into quadratics, you can just factor.